Yes, welcome back to the session. In this video, I'm going to discuss about Newton's second law of motion, class 11 physics. Okay, so look at the diagram here. This is the object of mass m which is placed on the horizontal surface. So here this is the horizontal surface. Let us assume there is no external forces acting on the object. Therefore, initial velocity of the object is 0. So initial momentum Pi is equal to 0. Okay, now if I apply some external force on this object, then the object position of the object changes from place to place. So after a small interval of time, this is the position of the object, and here velocity changes from u to v meter per second. So whenever velocity changes from u to v, the product of mass and velocity is called momentum, right? So we can write it as here p is equal to m into v. Okay, so how this momentum came here? Because of this external force, correct or not? So according to Newton's second law, force acting on a body is directly proportional to dp by dt. That means rate of change of momentum. Let us assume this is equation number 1 and this is equation number 2. Substitute 1 in 2. Then F is directly proportional to d by dt of P means mv. Okay, this m I am taking right side. F is equal to m into dv by dt. So what is the meaning of dv by dt? Velocity by time is called acceleration, right? Correct or not? So we can write it as F is equal to some constant k into m into a. Okay, if k is equal to 1, then F is equal to ma. So here k is called constant. Okay, so from Newton's second law we got finally F is equal to mass into acceleration. Okay, now coming to the units. So if you are going to calculate SI unit of force is Newton. SI unit of mass is kg. SI unit of acceleration is meter per second square. So therefore we can write it as 1 Newton is equal to 1 kg meter per second square. Okay, similarly if you want CGS unit, so CGS unit of force is dyne. So 1 dyne is equal to CGS unit of mass is gram. CGS unit of acceleration is centimeter per second square. Okay, so CGS unit of force is 1 dyne is equal to gram centimeter per second square. SI unit of force is 1 Newton is equal to 1 kg meter per second square. Okay, so based on this, we can calculate the relation between Newton and dyne. Let us see. So now I am going to calculate the relation between Newton and dyne. Okay, so just now we discussed 1 Newton is equal to 1 kg meter per second square, right? So therefore 1 kg means how many grams? 1000 grams into 1 meter means how many centimeters? 100 centimeter divided by second square. Look at this equation carefully. Here we have 3 zeros. Here we have 2 zeros. Total is 5 zeros. 1, 2, 3, 4, 5. What is the rest? Gram. Here centimeter per second square. Okay, so 5 zeros means we can write it as 10 power 5 gram centimeter per second square. So gram centimeter per second square is nothing but dyne, right? So we can write it as 10 power 5 dyne. So 1 Newton is equal to 10 power 5 dyne. Okay, so I hope you understand